On June 28, 2009, Stephen Hawking sat in his wheelchair at a cocktail party at Cornwall and King's College, Cambridge, beneath a banner reading, "Welcome Time Travelers." The twist was, he sent out the invites next day, so only the genuine time traveler come. Hawking later said in the documentary, "Maybe one day, someone living in the future will find the information and use a time machine to come back to my party, providing that time travel will one day be possible." Hawking and others have argued that you could never travel back before the moment your time machine was built. The concept of time travel is not recent. More than 100 years ago, Albert Einstein came up with his theory of relativity, in which he says that time slows down or speeds up depending on how fast you move relative to something else. Before that, we used to think that time is absolute, but this theory revolutionized everything and gave us new possibility. Einstein says time is relative. It can vary from different observers depending on your speed through space. You know what that means?
Time travel!
Believe it or not, time travel is possible. In fact, you are doing it right now. Every single second of every single day, you are advancing into your own future. You are literally moving through time, the same way you would move through space. I mean, here you are, 1 minute and 10 seconds into the future since the start of this video. You are reaching your own future, whether you like it or not. We are all always traveling forward through time. But that's boring time travel. We want to time travel relative to other people. Science, as we know, it allows for several methods to take the fast track into the future. Here's a rundown. This is the easiest and most practical way to get to the far future. Go really fast. According to Einstein's theory of special relativity, when you travel at speeds approaching the speed of light, time slows down for you relative to outside world. This is not just conjecture or thought experiment, it's been measured using twin atomic clocks. One flown in a jet aircraft, the other stationary on Earth. Physicists have shown that a flying clock ticks slower because of its speed. In the case of the aircraft, the effect is minuscule, but if you were in a spaceship traveling at 90% of the speed of light, you'd experience time passing about 2.6 times slower than it was back on Earth. And the closer you get to the speed of light, the more extreme the time travel. The highest speed achieved through any human technology are probably the proton whizzing around the Large Hadron Collider at 99.9999991% of the speed of light. Using special relativity, we can calculate 1 second for the proton is equivalent to 27,777,778 seconds, or about 11 months for us. Amazingly, particle physicists have to take down this time dilation into account when they are dealing with particles that decay. Muons are elementary particles similar to the electrons. They typically decay in 2.2 microseconds, but fast-moving muons take 10 times longer to disintegrate. This method is also inspired by Einstein. According to his theory of general relativity, the stronger the gravity you feel, the slower time moves. As you get closer to the center of the Earth, for example, the strength of gravity increases, time runs slower for your feet than your head. Again, this effect has been measured. In 2010, physicists at the US National Institute of Standards and Technology placed two atomic clocks on shelves, one clock 33 centimeters above the other, and measured the difference in their rate of ticking. The lower one ticks slower because it feels a slightly stronger gravity. To travel to the far future, all we need is a region of extremely strong gravity, and you know where it is. Black hole. The closer you get to the event horizon, the slower time moves, but it's risky business. Cross the boundary and you can never escape. And anyway, the effect is not that strong, so it's probably not worth the trip. Well, a trip to a black hole is hard, but what isn't hard is to subscribe. Scroll down and click the subscribe button, and also press the bell icon for future videos. Now back to gravity. Assuming you had the technology to travel the vast distances to reach a black hole, the time dilation through traveling would be far greater than any time dilation through orbiting the black hole itself. The situation described in the movie Interstellar is a good example of this, where 1 hour on a planet near a black hole is the equivalent of 7 years back on Earth. The most mind-blowing thing perhaps is the GPS system have to account for time dilation effect in order to work. GPS satellite orbits around 22,000 miles above Earth with speed of 14,000 km per hour. So they have good speed and less gravity, so time dilation kicks in, even though time dilation effect is minuscule. But without these corrections, your phone GPS capability wouldn't be able to pinpoint your location on Earth to within even a few kilometers. Another way to travel to the future may be to slow your perception of time by slowing down or stopping your bodily processes and then restarting them later. Bacterial spores can live for millions of years in a state of suspended animation until the right condition of temperature, moisture and food kickstart their metabolism again. Some mammals such as bears and squirrels can slow down their metabolism during hibernation, dramatically reducing their cells' requirement for food and oxygen. Could humans ever do the same? Though completely stopping your metabolism is probably far beyond our current technology, some scientists are working toward achieving inducing a short-term hibernation state lasting at least a few hours. This might be just enough time to get a person through a medical emergency, such as a cardiac arrest, before they can reach the hospital. In 2005, American scientists demonstrated a way to slow down the metabolism of mice by exposing them to minute doses of hydrogen sulfide, which binds to the same cell receptors as oxygen. The core body temperature of the mice dropped to 13 degrees Celsius and metabolism decreased tenfold. After 6 hours, the mice could be reanimated without ill effect. Unfortunately, similar experiments on sheep and pigs were not successful, suggesting the method might not work for large animals. Another method, which includes a hypothermic hibernation by replacing the blood with a cold saline solution, has worked on pigs and is currently undergoing human clinical trial in Pittsburgh. General relativity also allows for the possibility for shortcut through space-time known as wormholes, which might be able to bridge distance of billions light years or more, or different points in time. Many physicists, including Stephen Hawking, believe wormholes are constantly popping in and out of existence at the quantum scale, far smaller than atoms. The trick would be to capture one and inflate it to human scale, a feat that would require a huge amount of energy, which might just be possible in theory. We also need negative energy to make portal open, and nobody knows how to make negative energy. Attempts to prove this either way have failed, ultimately because of the incompatibility between general relativity and quantum mechanics. Another idea put forwarded by the American physicist Ron Mallett is to use a rotating cylinder of light to twist space-time. Anything dropped inside the swirling cylinder could theoretically be dragged around in space and in time, in a similar way to how a bubble runs around on top of your coffee after you swirl it with a spoon. According to Mallett, the right geometry could lead to time travel into either the past and the future. His ideas have not grabbed the rest of the physics community. However, with others arguing that one of the assumptions of his model is plagued by a singularity, which is physics speak for it's impossible. Time travel is filled with paradoxes. Physicists are coming up with different theories to do non-paradoxical time travel. We'll talk about paradoxes in some other video. If you could time travel to any year, past or future, which year would you choose and why? Let me know your thoughts in the comments below. Peace.